So hello guys. So welcome back to our channel. So today we are going to solve today's LeetCode problem. So our daily home for data structures, algorithms and competitive programming. So I am your host. So today we are going deep through workout of this LeetCode problem 1415. So this is a medium problem. So here in this problem we are going to solve this problem with combinatorial counting as well as backtracking. So we are going to cover it up completely. So the problem to code and full dry run with the sample test cases here and the basic mistakes and the time complexity analysis of this problem. So let's dive into this problem. So first let us see that. So here this problem is happy strings. So the problem says happy and you might think it is easy. So here in this problem, it is asked you to enumerate the combinatorial structure in the strict lexicographical order of this problem. So we have to pinpoint any one of the specific element and that requires you to understand the shape of the search space. So how to navigate it systematically and for the elegant solution, how to avoid building anything at all. So this problem is having the kth lexicographical string of all happy strings of length A. So within this, we are going to cover the topic of backtracking and combinatorics. So today we are going to build two complete solutions, a clean backtracking approach that generates strings in order and stops in the yearly kth position. And after that, a mathematical approach that directly computes each character of the answer using the structure of the search tree. So both solution explained line by line and full dry runs. So the complexity and the common mistakes, all of it. So let's see it. So this is the problem. So before seeing it, let's see what is lexicographical order. So a lexicographical order is a dictionary order. So first things, it is built from A, B, C. So the first comes is A, then B, after that C. So when comparing two strings of the same length, we compare left to right, character by character. So the first position where they differ determines the order. So for example, A is first comes and after that B, after that C. So A is less than B and less than C. So this is the string for the length 1. After that, AB is less than AC and it is less than BA and it is less than BC, and this BC is less than CA and it is less than CB. Okay, this is how this will go according to it. So the key insight is if we always try the characters in order like ABC at each position, the strings we generate are automatically in lexicographical order. So there is non sorting needed. So we get them in the right sequence for the free by the order we explore. So let's see what is backtracking. So backtracking is a systematic way to build all possible solutions by making choices one step at a time and undoing them and backtracking. So when we reach a dead end or a complete solution, it explores a decision tree depth first. So for this problem, at each position in the string, we have 2 or 3 choices. So any character from A to B and B to C, so anything may be except. So once we just place, we go depth first and build the string left to right. So until we reach the required length of n. Okay. So let's close this. So let's read the problem statement. So it is a happy string is a string that consists only of letters A, B and C. So the current character is not equals to the next character. So the two consecutive characters is not the same characters. So for all values of I from 1 to the length minus 1, that is string, they have said the string is 1 index. So for example, the strings are ABC, ACB, and this ABC, BA, BCC. So are all happy strings, and the string this AA is not, because both are consecutively same. For this BAA, this AA also same, and BB are consecutive, so it is, these are not happy strings. So here, given two integers n and k, consider a list of all happy strings with the length of n. In, they have said it is sorted in lexicographical order, so we have to return the kth string of the list, or return an empty string if there are less than k happy string of the length n. So they have given the size is 1 and the value is 3. The k value is 3. So the list is ABC. So it contains all strings. So within it, the third element is C. So 1, the n is 1. So ABC. So the kth value is 4. So now in the fourth value, there are only 3 happy strings here. That is A, B, and C. The size, with the size of 1, there are 3 possibilities, A, B, and C. The fourth element is there is no element, so we return empty string. So here it is ABA, ABC, like that we have more than values, that is 3, 6, 9, 12. There are 12 strings here. So the 9th string is this CAB. So CAB is being printed. So this is what we are going to solve here. So let's verify, we have verified these many strings. So now we have one formula. So that is, there are 3 happy strings of the length 1. So k is x is 4, the total count. So we are returning the value. So 3 is multiplied by 2 power 1 minus 1. So that is nothing but we can calculate how many strings that can be possibly get with the value of the current value. So that time we simply return the value 0. So our empty string. Okay. So let's see the backtracking approach. So the backtracking approach is the most natural, and we use depth first search to generate all happy strings of the length in n in lexicographical order. So counting each one. So when our count reaches k, we have found the answer. So record it and stop it there itself. So the steps are, first we have to check that if k is greater than, so first we can find a formula for it. How many elements can be present with the size of it? So there are 3 characters. So 3, it is multiplied by 2 power n minus 1. So using this formula, we can find maximum number of elements. So if n is 1, so it is 3 multiplied by 2 power 1 minus 1. So 2 power 0, it is 1. So 3 multiplied by 1 is, so if n is 1, we can find 3 values. So if n is 3, so it is 2. N minus 1 is 2. So 4. 4 multiplied by 3 is 12. So there are 12 possibilities. So first we can check if my k value is greater than this 3 multiplied by 2 power n minus 1. We can simply return an empty string. So if not, we can just start the DFS with the current empty string and a counter initialized with the 0. So at each DFS call, we will try appending different characters A, B, C in that order. So if we have to skip the character if both of them match the same character. Okay, if the current string is length is equals to n, we can increment the counter. If my counter is equals to the size of k, we can record the answer and stop all further recursion. Otherwise, the recursion will get deeper and append the character. We can just backtrack and remove the character. So let's write the solution. So first, we will find the total number of values or strings can be obtained using the happy strings. So for that, total is 3 multiplied by so 2 power n minus 1. So I can simply write it as 1 left shift. So it is nothing but 2 power 1. It is multiplied by n minus 1. So it is faster. So it is nothing but left bit shift. So it is faster and it is more faster and complex than the power function that is in the C++. So after that we can check it and return the value. So if my k is greater than the total, return an empty string. Okay. So now let's create string. So current as empty string. I'll create one string variable with current and I'll declare one more string for the final result. Initialize with empty string and a counter for the checking of the k value was size. So I'll initialize with 0. So now I'll write the DFS function for it. So I'll make it as private function. So in this private function, I don't want to return anything. So I'll make it as void. We'll deep through iterated through DFS. So the size n and the value int k. So after that, the current string and the final string. String address current. So the reference of the variable in the string, reference of the final value result, and count. So if so we have created the DFS using these values. So now we can check that once the result is set, we want to stop all further recursion immediately. So including all backtracking calls, the call stack is above. So every recursive call first check if the answer is already found. So if it is already found, we can just return the value. So this turns the full DFS into early stopping DFS. So if my result is not empty, we can return. So without this, the DFS would continue generating all strings even after finding the answer. So this is very requirement So we have to write this function. So if it is already found the answer, we can just return the value. After that, if the current size length, so the current string dot size. So the current size is equals to n. So when the current length has reached the n, we have built a complete happy string. So we increment the count to the total number of happy strings seen so far. So if count now equals to k, so this is the one we want to copy current into the result. So then the return regardless, so we cast the current size into the integer because the size returns the unsigned type. So for unsigned type, we can just use typecasting here, make it as integer. So now it will check that. So after that, we can increase the count by 1 and check that if my current count is equals to the value of k, my final result is the current value. The current thing is the final value. After that, we can return. So here we are checking it. The size is reached the length. So we built a complete happy string. So we increment the count, the total number of happy strings seen so far. So if the count now is equals to k, this is the one we want to copy to the current result. And after that, we can just return it. So let's try with the each other character. So for that, adding this for character c is equals to a. If my c is less than or equals to the character c and character plus plus. So I iterate through 3 times. So a, b and c characters. So here within that, if my current string is not empty and it is having the backside value, so that time we can continue to the next one. So like happy string constant is no two consecutive characters can be same. So current dot back, if you use current dot back, so it will give the last character of the string that we have built so far. So if the character we are about to place matches it, we skip the condition. So if my current string is not empty and my current string's previous character is equals to the current character, we can continue. Okay. So if it is not an empty string and as well as it has the previous value, so this is what the condition it will make the happy numbers. So after that, we'll write the backtracking structure. We'll put the chosen character into the current value and recurse to the continuous building. So after the recursion is returns, we pop the character back off and restoring the current value to their current state. So we just need to current string dot pushback. So within this pushback, we will give the value C. So if you do that, it will add to the character. So using this character, if you do that, it will get back to the value. After that, we have to backtrack. So DFS of the value of n and k. The next one is the current string. So we just give the value current string and the result string. So after that, the count. So after calling it, it will get back to it. So finally, we have to remove the current character. So current dot. So for removing, we have to use pop back. So it is being pushed and backtrack and remove the value. So this is nothing but backtracking here. So this canonical backtracking, this is the canonical backtracking structure. We push the chosen character and the current string and request to continue building. So after the recursion returns, we pop the character back off and restoring the current to its previous stage. So this is nothing but undoing the adding of this character. So this is what make it as the backtracking. So the string is reused across all calls. So there is no copies is needed. So here is the solution of the first approach. So here we have to call it. So after this if condition, we have to call DFS n k and the current string. So it is not here. We have to go in the main function. So DFS n k current string, result string and the count. Okay. So now we have to return the result. Return result. So let's try to run it and see if it is passes the all test cases. So this backtracking approach is passing all the test cases here. So let us see one more approach for this solution. So the next one is direct computation. So using this, we can compute each character of the answer one position at the time. So in this position, in the next method, we use a nested for loop and a subtree to iterate through the every solution. But here, this is what all we need. So we just run it and submit the solution. So it is being passed with all the test cases. So let us see the basic mistakes of this solution. So the common mistakes is that they will forget the earlier exit of this k value. So here we have earlierly returning. So if you forget it in the backtracking, it will not complete it. It will entirely run through it. So it wastes the time generating strings that don't exist. So always add the yearly exit. So if you pass the current by value instead of the reference, every recursive call makes a copy of the entire string. So here, most of the people would do is they will pass the string by reference in the backtracking. So if you pass the current value instead of the reference, so every recursive call will create one more string. So if the n is 10, this means copying strings of the length up to 10 is this every level of this 1024 node tree will significantly overhead. So make sure always pass the current string and the result string and the total count by the reference, not the exact value. So if you do that, it will overhead of the tree. So next one is people would forget for the god of result.empty. So make sure you have to check that if the string is empty or not. So without this guard, so it will continuously generating all type of strings. So make sure you will not do the same mistake here. So in this problem, we have seen about backtracking solution. So in this backtracking, it will generate every type of strings and store it to it. So finally, when it reaches the same number, it will return the current string. Before that, we can check that using this total formula, we can calculate it, and if it is exceeds the total value, we can just return the empty string. And here we have using a for loop for calculating and backtracking it. Before that, we have three variables to store the values. So that's all for this today's video. So if you feel this video is helpful, please like it and subscribe for the daily problem walkthrough and stay right there and make sure to code every day.